Hello friends, this is Durga from ITVersity. Um, Today, as part of the live event, I'll be talking about YARN, which is nothing but yet another resource negotiator. Before getting into the details, let me announce a few things. So lately, I have started a series of online meetups where the content will be provided for free. There will be some sessions which will be broadcasted for free, but after a while, they might become member exclusive, especially with respect to NiFi. But with respect to Spark, which I'm going to start next week, all the sessions will be free and they will stay for free forever. That being said, if you want to be a member to our YouTube channel, you can become a member. The link to become member is there as part of the meetup event invite also. However, if you want to explore, you can use this link which I'm sharing as part of the YouTube live chat, and you can become the member. The advantages of becoming the member are you will be getting access to the exclusive content for members. And also, if you have any questions, you can ask those questions as part of these sessions, and I'll prefer your questions over others. Everyone feel free to ask any questions at any point in time, but try to stay relevant so that I will not be distracted too much and I'll be able to answer the questions. With respect to members, I might take some of the irrelevant questions also, but if they're completely off of the topic, then I might not be able to answer even for members. If there are too many questions, then I will prefer member questions because they're paying for every month for becoming members, and hence I will prefer their questions. Otherwise, I will try to answer as many questions as I can. That being said, as part of the series, so far I have covered quite a few topics. I have covered what is HDFS, and I have given introduction to big data ecosystem and all those things. All the videos that are part of this series are available as part of this playlist. It is available as part of the meetup invitation itself. You can go to these and you should be able to catch up with respect to the topics that are covered so far. Even if you miss any of the sessions, you should be able to go to this playlist and you should be able to take it further. If you want to be part of the meetup and RSVP for these live sessions so that you can watch live and learn few things, you can join our meetup group. This is the link for our meetup group. And once you join the meetup group, you can actually go to the events page, and you should be able to see all the events that are about to be broadcasted soon. And you can RSVP and you can get notifications whenever the sessions go live or about to go live, and you can watch through meetup. Or if you're already a YouTube subscriber, you might get the notifications whenever I announce an event on YouTube. All these meetup events will be broadcasted through YouTube, and hence you should be able to watch. That being said, now let's get into the agenda. So the agenda is all about YARN. I will talk about YARN architecture by previewing using our labs. And then I will talk about how to run MapReduce jobs using YARN. MapReduce is getting outdated, and hence I will not be spending too much of time on this topic. Then I will actually showcase how to run Spark jobs using YARN. Then I will talk about YARN application lifecycle, then Spark job execution lifecycle, and I will just give an overview about YARN schedulers. I will not be getting into too many details with respect to YARN schedulers. As a developer, it is getting less relevant as it evolves. You don't need to worry too much about these underlying nuances with respect to the framework. As long as you are comfortable with the APIs, and as long as you are comfortable with how the code execute, how to tune the code, you are good to go. You don't need to worry too much about the schedulers and some of the intricacies of the underlying framework. As the series is supposed to be with respect to Spark, to submit the Spark applications, YARN is one of the cluster types. There are other cluster types also. I will be covering those things when I get into this Spark. For now, I will just give an overview about YARN, how the Spark jobs are submitted using YARN, and how to go to the details with respect to the lifecycle. That being said, if you are completely new to big data, the session might be a bit tough to understand. But once we go through the Spark, and if you come back and try to review some of these things, you will understand a bit better. This session has to be viewed multiple times to understand some of the concepts which I'm talking about. But even if you do not understand after 2 to 3 iterations also, that's fine. Over a period of time, you'll get it. That being said, now let me connect to the lab and let me talk about the yarn architecture, and then we'll take it further. All the material which I'm using as part of these sessions is part of my GitHub account. You can get the content for free. The URL is nothing but github.com/dgadraju/ITversity books. Let me paste this link as part of the YouTube live chat, and you can actually watch, click on star and fork to get updates whenever I make some changes to the code base. As of now, these ITversity books have 3 folders. The main folder is nothing but Data Engineering Bootcamp. If you click on this, there is quite a bit of content with respect to basics of programming using Python. There are videos also related to this. I will update the details and share those things at a later point in time. For now, as we are talking about the big data ecosystem and Apache Spark using Python, let's get into the notebook that is relevant for today's session so that you can access the material online. You can go into this big data ecosystem overview and you can click on this at another resource negotiator, and whatever I'm going to cover today is available here. You can use this as reference material. If you are using our labs, you can actually clone this repository and you should be able to run these things directly as part of the labs. The way it will be is like this. So you can actually go to gw01.itverse.com or gw02 or gw03, depending upon the gateway node assigned to you when you sign up. You should be able to see the things like this. Okay, and you should be able to run the code directly off of this. So there are a few advantages subscribing to the labs. In case if you are interested to subscribe to the labs and access this material and also practice directly off of this code itself, you can actually sign up for the labs by going to this link. Okay, so that being said, let's get into the details. So this is what we are going to cover today. First, we'll talk about yarn architecture. To go to the yarn architecture, once you sign up for the labs, you'll also get access to something called as Ambari. Ambari is nothing but a management tool or cluster management tool. It also provides wizard to set up the cluster. As administrators, we'll take care of dealing with Ambari. You don't need to worry too much about Ambari. All you need to understand is how to read the information from here. Administrators are the ones who will have access to the Ambari, and they will take care of setting up cluster using Ambari. The regular users like you, who are supposed to be developers as part of these labs, you will not be getting access to restart the services and all. You will only be able to review the information that is available here. Now, to understand the architecture of any service, you can click on that service and you can take it from there. In this case, we are talking about yarn. I have gone through some of the other details as part of the earlier videos as part of the playlist. If you go to the playlist, here I have given overview of big data clusters, both on-prem and cloud. You can actually go to that video and understand a bit more details than what I'm covering here. For now, you can actually go to Ambari, and you can click on yarn to understand the architecture. These details also covered quite a bit earlier. Yarn also follows something called as master worker architecture. Traditionally, it used to be called as master slave architecture, but now people are getting away from the word slave. So you can consider it as a master worker architecture. In this case, resource manager is the master. It will be set up only on one node in the cluster or two nodes if you want to configure high availability in production. And then app timeline server is primarily for the historical jobs. So whenever we submit a Spark job or MapReduce job on the cluster, it will be submitted as a yarn application because we are using yarn as the framework. Once the job is done, the information related to those applications is served by this app timeline server, because the server or web service, when we start the so when we actually submit a Spark application or MapReduce application using yarn, it will create a temporary web server, and that web server will be terminated once the job execution is completed. As the web server will be terminated, if you want to get the details about that web server to to do some postmortem and understand where it is failing, you have to you should be able to access that information, and the framework will provide that information in the form of app timeline server. Any applications that have failed or are successful, if you want to do any postmortem after they are completed or killed, then you can go to the app timeline server and you should be able to see the details. That being said, app timeline server is primarily for the historical applications. The applications can be either MapReduce application or Spark application. Yarn is a generic framework, and different distributed computing engines such as Spark, MapReduce, etc. can be plugged into Yarn. From the Yarn perspective, we call it as the Yarn application. From Hadoop perspective, we call it as MapReduce application. From Spark perspective, we call it a Spark application. But at Yarn level, it is called as Yarn application only. And for each and every application, whether it is Spark related or MapReduce related, there will be a web server that will be created and it will be terminated. And the app timeline server will give you the details about that web server that is created and terminated when you submit a Spark application or MapReduce application. That being said, where the application will run, the application will run as part of the node managers, and these node managers will be configured on the same nodes where data nodes are also running, so that there is a concept called as data locality. I would highly recommend you to Google around and understand what this data locality is. To leverage the data locality, all the data processing will happen as part of these worker nodes. And on the same worker nodes, we will have data nodes also. Data nodes are from HDFS. And when it comes to MapReduce job, they will be executed as map tasks or reduce tasks on these worker nodes. If it is a Spark application, it will be executed using something called as Spark executors. And those executors also will be running on these worker nodes only. Very soon, I will be submitting a Spark job and you will understand what I'm talking about. If you don't understand at this time, don't worry too much about it. Now, I'm reiterating, resource manager is nothing but the master in Yarn. There might be more than one resource managers in case if we configure high availability for resource manager. Node managers on worker nodes are node managers on worker nodes are the worker components of resource manager. Node managers collect usage information from respective nodes and send the details to the resource manager as part of the heartbeat. So every frequent interval, there will be something called as heartbeat that will be sent from the node managers to resource manager. As part of the heartbeat, it will actually send the details such as CPU usage, memory usage, etc. So that resource manager understand on what nodes the job should be submitted depending upon the load on the cluster. Resource manager keeps track of the usage of the cluster. You can review this information using resource manager UI. So at any point in time, if you are using Yarn for your MapReduce jobs or Spark jobs, you should be able to understand the load on the cluster by going to resource manager UI. How to access resource manager UI? Now, if you go to Ambari, if you are using Ambari as your cluster management tool, if you go to Yarn, here you can see the quick links and you can click on this resource manager UI. It will redirect you to the page where it will provide the details about the Yarn cluster, which is typically used for the submitting the jobs and executing the tasks related to the jobs. Now you can actually go to the about nodes here. It will give you the details about each and every node. You can see here as of now on worker node 5, there are 2 containers running. 2 GB is being used. 22 GB is available, and 2 vCores used and 2 vCores available. So this is the information which is sent by the node manager that is running on this worker node to the resource manager, and resource manager will collect that information and provide you as part of this simple UI. You can see these details are coming from all the worker nodes, and typically the load will be balanced on all these worker nodes. To get the cluster level capacity, you can actually look at this cluster metrics. You can see that total memory allocated for this Yarn is 120 GB. Yarn is the one which will take more memory than anything else. If you are already familiar with big data, and if you have been working in big data for quite some time, at ITVersity, we have created a video on Yarn tuning. You can actually review that to understand more details about how this memory is computed and all those things. But as of now, we can see that 120 GB is allocated from this cluster to Yarn, and 60 virtual cores are allocated to the cluster. And you should be able to relate this with the actual cluster capacity. For that, you can go to hosts in Ambari. And if you go to hosts, and if you look at the worker nodes, there are 5 of them. We have 40 cores and 160 GB RAM. Out of these 160 GB RAM, out of this 160 GB RAM, I have given 120 GB to actually process the data using Yarn as framework. So almost 75% of the memory is allocated to Yarn from these worker nodes. And when it comes to vCores, these are physical core capacity. We have 40 of them, as we have 5 worker nodes, as we have 8 on each. We have total 40. There is something called as vCore multiplier. It is used, and we have given 120 of them, even though we have only 40. Sorry, we have given 60 of them. Even though we have 40, we have given 60. There is something called as vCore multiplier. And I have provided those details as part of the Yarn tuning video. You can go to our YouTube channel and you should be able to watch it. Someone is asking the question. Let me see if it is available so that I can share the details with you. Okay, so let me go back to the other browser, and then let me go to YouTube channel. I don't want to spend too much of time to explain those details with you. For now, just you can actually search for ITVersity Yarn tuning. Okay, I have created. How come it is missing? Let me see. I think this is the one. Yeah. Let me confirm real quick. Yeah, this is the one. You can actually watch this video to understand more about it. So there are a few questions. Let me take these questions once I cover some of these aspects, which is part of this notebook. Okay. So yeah, as I have reiterated, app timeline server is to keep track of Yarn applications submitted on the Yarn cluster. On the cluster, we can run MapReduce jobs as well as Spark jobs using Yarn, and we will be running those jobs, and we will see how it works. Let me take few questions here. If you are a member, you can ask those questions, and I will be giving priority to your questions. But I will go to the other questions also. If they're not relevant, I will not answer those questions. I will just dodge them. So Sushant is asking, this is same architecture of Hadoop master and worker node. What is the advantage of using Yarn? I don't know, Sushanta. It's the question sounds very naive, so I will not be able to answer that question. You have to go back and watch each and every video which is covered in the series, so that you get some context, and probably you might be able to frame the question in a better way. Ranjit, I have already answered your question. You have to go to that YouTube video which is shared as part of the chat, and then you should be able to get the better understanding about vCores and cores, etc. Narendra is asking, could you please relate name node and data node with Yarn architecture? Just a brief info. Yeah, so name node and data node are related to HDFS, which is just a file system. Typically, we get data into HDFS and we have to process the data. To process the data, we use either Spark or MapReduce. MapReduce is getting outdated. Spark is getting the de facto standard with respect to data processing. So when you actually use Spark, it requires some cluster management tool so that Spark can leverage that cluster management tool to process the data. Spark can use Yarn as one of the cluster management tool, and Yarn will take care of understanding how the cluster is being used from the data processing perspective. HDFS is for storage, and Yarn is from the resource management from the data processing perspective. So both together is Hadoop. Yarn with MapReduce plus HDFS, which is nothing but a file system, or Hadoop. Slowly, the definition is changing. Hadoop is slowly fading out, and eventually you might not even hear the term Hadoop at all. Okay, There will be file systems instead of HDFS. The market is considering other file systems such as S3, Azure Blob, DBFS, which is Databricks file system, and then there is something called as Menayo, which is a open source S3, so on and so forth. So even the term HDFS, Hadoop, Yarn will slowly fade out. They are still relevant. They will stay for another couple of years probably, but eventually those will be faded out. And as a developer, you just need to think about storage and the processing. Storage can be any file system. Processing will be Spark, and Spark can execute using one of the 4 frameworks that is available. Let me talk about that for a moment so that you understand the gist of it. So if you go to spark.apache.org, which is the Spark official page, you can go to the latest release, and then you can actually go to deploying, and you can see here Spark standalone, Mesos, Yarn, Kubernetes. You can submit the Spark jobs in one of these frameworks. Yarn is the one which I'm covering. As part of the course, we'll also talk about Databricks. Databricks will be using Spark standalone. You will understand that very soon. Mesos and Kubernetes are other 2 alternatives. Mesos is not gaining that much of a momentum. Eventually, it will be either Spark standalone or Kubernetes if Yarn eventually fade out. Okay, but Yarn might stay for quite some time. As of today, Yarn is used at least 60 to 70%. The market cap might reduce to 30% or something because Databricks uses standalone. Kubernetes is used in private clusters. Yarn is still 60-70%. The reason is AWS EMR and Google Dataproc also uses Yarn, but eventually it might fade out. If they decide to move away from Yarn, then Yarn will fade out. But from Databricks perspective, it is primarily Spark standalone. Okay, so now let's talk about running MapReduce jobs using Yarn. First, let us run simple MapReduce job and see what happens. We'll be using Hadoop examples that come as part of the setup process itself. So whenever we set up a cluster, there will be examples that will be provided to us. Even if you actually set up Spark locally, even Spark provides you examples. You can leverage those things and you should be able to run. In this case, this is how the Hadoop MapReduce job can be submitted. It is part of something called as Hadoop MapReduce examples.jar, and you should be able to run a program called as random text writer. In this case, I am setting replication factor to 1 because I'm just running to just demonstrate to you, and I don't want to waste too much of storage. And this is the target location to which it will be copied. Now, 1 minute, let me see. Yeah, now what it will does, it will actually generate 10 GB of data on each and every node in the cluster, and you can actually see the data in the target location. Let me see if I have some other job. Yeah, I have only this job. It will take a bit of time, and hence I'm not running. But if you want, you can actually copy this, and you can pick up this random text writer from the examples. If you set up Hadoop locally, you can search for this Hadoop MapReduce examples.jar, and you should be able to run it. So if you are using cluster, you can directly run it, and you should be able to see. That being said, now let's talk about how it will be executed. Typically, data will be processed using map tasks and reduce tasks. Map tasks read the data and perform row-level transformations. Reduce tasks read the output of map tasks and perform transformations such as joins, aggregations, etc. Instead of using this, I will actually run something and I will demonstrate so that you really get a gist of it. Let me see. Let me actually connect to the lab here. It is deleted. Let me actually connect to the other one. Okay, it should be there somewhere. Okay, that's fine. I will actually let me recollect where I have. Okay, let me do this. Let me copy this. Okay, so if you do not find this file, the way you can search is like this: find. You should know where the files are typically deployed. I am giving the path. So in my case, it is 2.6 cluster, and then I can say name Hadoop star examples star.jar, and this is the file which we can use. Okay, and then you can say Hadoop jar. We can also use this one actually. So let me update this. So the location is nothing but this one. Let me copy this. Okay, and then the program which I want to run is nothing but word count. Word count takes two arguments. The first one is the source from which I want to read the data. It is nothing but public random text writer. I will actually check in this code into the GitHub also, so that it actually uses the correct code. For some reason, I missed this out. I will first walk you through what this folder contain, then I will take it further. So if you actually look at this folder in our HDFS, by running HDFS dfs-ls and paste it, so it is writer. Yeah, I forgot to copy R. If you look at this, each file is 1 GB. I have actually demonstrated as part of the last session also. We can actually say -h and hit enter. Each file is 1 GB, and we can actually say HDFS FSCK. Let me copy one file here. Blocks, locations, files. It will give us the metadata. You can see each file have 9 blocks. Now, if I try to process this data, let me actually process only one file, because if I have to process all 30 files, it will take forever. It will take quite a bit of time. Let me paste it here. This is my source location from which I want to read the data and perform the word count and write to this location. Now, if you relate to that, to the explanation which I have provided here, the first bullet point says map tasks read the data and perform row level transformation. If you look at the code, there will be map logic. If you go to the MapReduce, and that map logic will actually read the data from this file. It will have the functionality to read the data from the file which is passed as the input, and then it will apply the row level transformation. So it will take each line and it will break that line into words, and that is a row level transformation which it is going to perform. The output, which is nothing but the line which is broken into words, will be passed on to the reduce. And between map and reduce, there is a concept of shuffle. That's what the shuffling is defined here. So map tasks read the data and perform row level transformations. So a line will be broken into words, and then reduce tasks read the output of map tasks and perform transformations such as joins, aggregations, etc. In this case, we are trying to perform word count. Word count means for each and every unique word, we want to see how many times it is repeated in this file, and hence it is called as aggregation. So reduce function will have the functionality to perform that aggregation. Between map and reduce, there is something called as shuffling. I'm not going to get into too many details with respect to the map, reduce, and shuffling, because the primary agenda of today's session is about yarn framework itself, not related to map, reduce, shuffling, etc. And I'll not be covering about Hadoop MapReduce as we get into the course, because as part of the course, we will be primarily focusing on Spark. In Spark, I will talk about something called as narrow transformations and wide transformations. The narrow transformations can be visualized as map tasks, and wide transformations can be visualized as reduced tasks. You will understand those details when we actually get into the Spark details. Today, I'll not be getting into too many details even with Spark, but I just want you to get a gist of these words: map tasks, reduce tasks, shuffling, etc. Map tasks will typically read the data from the input path and perform certain row level transformations, such as breaking a line into words, because we are trying to perform word count. And then reduce tasks will take care of doing the aggregations. The framework will take care of shuffling between map tasks and reduce tasks. We do not have to get into too many details at this time, because the MapReduce is fading out. I think I have copied this material from Hadoop administrator course. That's why it is referring to administrator here. Let me put this way. Okay, this particular application word count is a MapReduce job, which will get us word count saved into output path. What is output path in this case? Output path is nothing but user who am I random text title. I will run it, but before running it, let me validate whether that folder already exists. If it already exists, I have to delete, otherwise the job will fail. So there seems to be few questions here. I will cover those questions in a moment. Okay, it is not there, so I should be able to run it. So if you are using our labs and if you use these Jupyter notebooks, you should be able to run this code without making any changes. It will automatically read the file, and then it will actually process the data. You can actually watch by running yarn application -list command to see the list of commands that are running, and you can see the user details here. And this is what MapReduce job that is running. And you have something called as yarn application UI. You can go to this location and you can see how the job will be executing. You can also get the details directly using the CLI also. So in case if you want to get details about a particular application, you can actually say yarn application status, and the application ID is nothing but this one. So I can use that application ID and see how it is running. So as of now, the progress is 43.34%, and it is still running. You can also get other details by going to the yarn application UI, because this is running behind the kind of a private cloud. We will not be able to access these URLs directly. We have to do something called as Foxy proxy and all. But actually, it have provided the output here. I think the job is executed now, and you can actually go to this output to understand how the job is executed. One of the things which you should focus is on number of splits. And if you look at this, the number of splits is 9. From where this 9 came from? If you go back and if you review the output of HDFS, DFS, sorry, not DFS, but HDFS FSCK command, when I pass the file name, the output contain 9 blocks. So by default, the number of blocks in the file will be considered as number of splits to process the data. Even when we get into the Spark, we'll see this. So don't worry too much. Sorry, you need to understand the relationship between the number of blocks and number of splits when it comes to MapReduce jobs. When it comes to yarn jobs, we talk about executed tasks. So you need to understand the relationship between the blocks of the file and the executed tasks as part of the Spark application. Once again, I am reiterating, if you are actually watching this for the first time, if you don't have prior experience, some of the theory will be very tough to digest. You might have to come back to this once again once we cover Spark in detail, so that you can relate whatever terms I'm using here with the concepts related to Spark. Now, let me take some questions before we proceed further. You can actually go to the target location and you should be able to see the details with respect to word count. We'll be doing that when we actually run the Spark jobs, if not today, at a later point in time. At that time, we will review the output. For now, I'm not going to review the output. I just want you to understand some of the explanations which are provided here. That's why I just ran this job. Before going further, let me take a few questions here. I will start with Jishan's question. What about Zookeeper? Will that go away also? So from the developer perspective, Zookeeper is never very relevant. So you don't worry too much about whether Zookeeper will stay or not if you are aiming to be a data engineer. It might still be there when it comes to the clusters like Databricks or AWS EMR under the hood, but we might not use it anywhere as part of our development process. It's not a developer skill at all. Zookeeper is always a Hadoop administrator skill. In microservices, some of the application developers tend to use Zookeeper, but now they have better alternatives than Zookeeper. So Zookeeper is not used by developers these days. So don't worry too much about Zookeeper. Okay, so Praveen is having some issues. That's fine, Praveen. I don't understand your thing completely, but that's fine. So Hemant is asking, when you say standalone, Spark can alone handle jobs on the cluster without other third-party cluster management tools. That is correct, Hemant. And when it comes to Databricks, it uses standalone, and we will see that. And I have seen not only Databricks clusters, but also some of the on-prem clusters using standalone. So standalone will be there. Initially, I thought it is developer only, but these days even production workloads are running using Spark standalone, which is native to Spark. But it requires some setup process. You have to start that standalone master and workers so that it will help you in submitting the jobs. So I will take this question from Praveen, which is related to Zookeeper. Okay, so Praveen, you were asking all Hadoop administration questions. I will take all your questions in one shot. So don't worry too much about those things. Okay. Anand is saying Spark standalone is vulnerable. I don't know, Anand, from where you have made that statement. So I cannot comment on that. So Praveen is saying we are using Nginx, Load Balancer, Kafka, NiFi, Hadoop, Cloudera, Elk, Elasticsearch, Neo4j, GraphX database, and the search engine to search for people and relationships. This is the goal. So I don't know why you were highlighting all these things, Praveen. I do not understand, and I'm not 100% sure how it is relevant. And the intention of this session is primarily for data engineers and developers who want to understand the Spark more than administrators. So I might not be able to get into too many details about the information you are looking for. Okay. That being said, I think all your questions are related to administrator. For now, let me keep them aside. Definitely, we can take these questions sometime in future. Some of the topics that might be relevant to you, which I will be creating over a period of time, is probably CDP. I want to do some workshop on CDP. I might get into the Kubernetes based approach. At that time, you will see value, but compared to the data engineer or developer related sessions, Hadoop administrator sessions will be on the lower side. Okay. So that being said, okay, let me take these questions. I think let me see if they are relevant. Otherwise, I will dodge those things. So Hadoop cluster, name nodes, yarn node manager, Spark thrift servers, yarn is getting down. Ultimately, we are having the capacity issue. Okay, I can't comment on those things which are specific to your platform. Unless and until I'm employed, I can't do that. I have to be a consultant to get into those details and help you. Okay, and when it comes to even offline, I will not be able to get into those details, Praveen. I am extremely busy and I might not be able to help you too much on that. And you are saying Hadoop administrator is the heart of Hadoop implementation, even if you use AWS or Azure with Hadoop. That is the incorrect statement. If you are setting up a Hadoop cluster on AWS or Azure, where the cluster will be up and running all the time, then you are not making a good choice. On AWS, you should set up clusters using EMR. On Azure, you should set up clusters using Databricks, where the clusters will be set up based on pay-as-you-go model. Okay, the days where you used to provision the cloud with infrastructure as a service and setting up the cluster on top of it are gone. No one is doing that way, and if someone is doing it, then they'll be burning a lot of cash and they will be getting a very less ROI. Even the POC clusters, no one is getting into that mode. Okay, so setting up Hadoop clusters on AWS or Azure is gone. Either you have to set up AWS EMR or GCP Dataproc or Databricks on AWS or Databricks on Azure. That's the way things are working these days. Now let me get into the details with respect to running Spark jobs using YAR. So when it comes to running Spark jobs, there is something called as Spark examples.jar. You can actually copy paste this as part of the CLI and you should be able to run. Or you can also run directly from here. Okay, the location has to be correct. This might not be the correct location. Let me search for this file. By saying find user HDP 2.6. And this is the location where we have the examples file. So we can leverage this to run. Okay, so I have to copy and paste this entire path here. Okay, and this is the input path which you want to run. However, if I run this, it will actually provide you a lot of output on top of the screen, and hence I'm not running it. Okay, but if you are interested, if you are this customer for the lab, you can run it here. Even then, I don't recommend to run it here. Unnecessarily, it will waste a lot of your time. So rather than running this directly, let me actually launch Spark Shell, which is nothing but Scala-based Spark using command line. And then I will actually write the code about getting the word count from the input location. The input location is nothing but this one, public random text writer. And the output location is nothing but this one, because this is the user which I'm using to run this. Okay, so let me actually demonstrate to you real quick about how you can leverage the cluster to submit the or to write the ad hoc code and take it further. Just give me a moment, okay? So here you can say Spark2-shell, because I have 2 versions of Spark in my cluster. If you want to get those details, you can go to Ambari, and then you can actually see here we have Spark, which is nothing but Spark 1.6, and Spark2, which is nothing but Spark 2.3. Okay, and then you can actually go to the terminal, and then you can say Spark2-shell --master yarn. And in our labs, you have to use something called as conf spark.ui.port equal to 0. Otherwise, as I have mentioned to you earlier, whenever we submit a Spark job, there will be a web server that will be up and running as long as the job is running. And as this is a multi-tenant environment, the default port, which is nothing but 4040, might be used by someone else. By saying Spark UI.port equal to 0, you will get one of the available ports on the server, and you will not be running into out of port issues. Okay, so that is the purpose of this Spark UI.port equal to 0. And then you can actually say num executors as 4. So this is how you can actually control the runtime behavior. Don't worry too much about this num executors and all at this time. We'll talk about those things as we proceed further once we understand Spark in depth. So starting from next week, I'm going to cover at least 2 sessions a week on Spark. Make sure you sign up to Meetup and follow there. I will share the links once again once I demonstrate here. Now, how the code will look like, the input path is nothing but public random text writer, and I can pick a file from there. So I can actually say val df equal to, so this is the Spark 1.6 way of getting the word count. In Spark 2.3, there is a different way of dealing with this, but most of the APIs which we use in Spark 1.6 are available even in Spark 2.3. Okay, just to demonstrate how the MapReduce code will be look like, I am actually using Spark 1.6, but the main course will be completely on Spark 2.3. We will not be using Spark 1.6 as part of our live sessions with respect to Spark, because as data engineers going forward, we are supposed to use Spark 2.3 data frame APIs, not the core APIs. Core APIs are for the low-level programmers who are actually working on improving the Spark engine. Developers or data engineers who are building applications using Spark APIs should focus on Spark 2.3 data frame APIs or Spark SQL. And those are the topics which will be covered starting from the next week. Okay. That being said, now I can say sc.text file. In this case, I'm trying to read the data from the file. So I should not be naming it as df. It should be RDD. Actually, we are using the Spark 1.6 version. And then I can give the path, which is nothing but public random text writer part -m -5 zeros. Okay, now the RDD will be created. You can actually say rdd.count to get the number of records, and then you can take it further. You can also iterate through the RDD, and you can print on the screen by using appropriate APIs. I'm not getting into too many details with respect to that. Now, I will actually go through one record by saying rdd.takeoff1 for each println. And we should be able to see the first record from this. You can see there's a very big line, and we want to divide into words, right? So this line has to be divided into words. How to do that? The way you can take care of dividing this line into words is by using an API called as flatmap, which is nothing but a narrow transformation in Spark, and you can take it further. So the code will look like this. I'm creating a variable called as words. Okay, and then rdd dot flatmap. In a Scala-based approach, we don't need to give the names for the arguments. We can use underscore like this in some of the cases, and hence I'm using that. So you can also give a name to that argument if you want, but in this case, I'm not giving the argument name. If you want to give the argument name, then it will be like this: a implies, or line implies line dot, or I can directly say underscore dot, and we are good to go. Now we can run this, and it will actually create a RDD where each element will contain one word from our input data. Okay. Now I want to perform the count, but before performing the count by using reduce by key, the reduce by key API expects the data structure to be a RDD where each element is a pair. As of now, each element in this RDD is one string, but with respect to using reduce by key to aggregate by a key, we have to convert it into a pair. To convert each and every word, let us see how the words will look like. Words dot takeoff 10 dot for each println. So now we have to convert each of these words into pairs. So it should be like this. So this should be converted to something like this. That is called as pair. For that, we can use an API called as map. So I'm actually saying val word tuples. For each string, I want to convert into tuple. Flat map is primarily to if the transformation creates a collection. If you want to explode the collection and get individual element as part of the RDD, then we use flat map. If you just want to transform one record to another record, in this case, a record which is of something like this to a tuple which I have shown earlier, we use map function. As part of the map, you can also perform case conversion. If you have a social security number and if you want to get only last 4 digits, those also can be taken care as part of the map transformation or as part of the logic that is passed to map. So in this case, I'm using something called as anonymous functions in Scala or lambda functions if you relate it to Python. If you're not familiar with Scala or Python, you will struggle to understand this code. As we get into the course, we'll be covering primarily using Python. I will do a quick recap of Python before getting into Spark-based APIs so that you understand some of the nuances. For now, if you're completely new to Scala or Python, if you don't understand this code, just ignore, don't worry too much about it. As we proceed further, you can pick up those skills and you should be able to relate and you can understand. That being said, now I can say words.map and I can say word imply word comma 1. So I'm converting each and every word into a tuple. Now you see the word tuples is a paired RDD. So it is of type RDD, but each element have a pair. One of the elements is of type string in that pair and the other is of type string, integer. Now I should be able to create a variable called as word count. And the API which can be used is nothing but reduce by key. Okay. Reduce by key takes 2 arguments and the output is nothing but adding those 2. So you might struggle to understand reduce by key even if you have experience. I will not be spending too much of time here. What I'm trying to do is I'm actually getting the count of each word using this reduce by key API. It will hold the words like this and it will add all the ones and it will give the word count. This is how the wide transformation, which is nothing but reduce by key, can be implemented. And then we can actually save this. So we can say word count dot save as text file in case if you want to save it as text file. And you can say /user/training live demo word count. It will be saved to this location. The word count will be saved to that location. Okay. And this is how you can write the code without creating intermediate variables directly. If you want to use PySpark, you can launch PySpark like this and you can actually run the word count. If you look at the code structure, it is almost same as the Scala structure. And hence, I'm not going to demonstrate how to take care of running this code using PySpark. In case if you are interested, you can go through it and you can take it further. We will come back to this when we actually get into the Spark so that you get more and more insights about this. After running the jobs, let us also review the UI to monitor either running or completed jobs. For that, you can actually go to the Ambari here, right? And you can go to yarn. Okay. As of now, the session is still running. You can see here the session is not closed, right? It is still running. And hence, you should be able to review the output. For that, you can go to the Resource Manager UI by clicking on this quick links and go to Resource Manager, which is already open here. I can refresh this and I can go to this running and I should be able to see the Spark session here. So this is the one which we have launched and you can see the details here. You can see the application master here. You can click on this and you should be able to see the details with respect to the UI. We'll spend quite a lot of time on this once we get into the Spark. There will be 1 or 2 sessions only to cover all the aspects of UI. Don't worry too much about this UI at this time. Okay, but you can navigate to the UI by going to the application master link as long as it is running. Now, if I complete this, or if I quit from here, now the web server will be done. It will be closed. Now, if I refresh this, you see it is not showing up anymore because it is not running. You can actually go to finished, and you should be able to see that job here. And if you see here, it is now saying history, and you can click on this history to go to the Spark job history. Okay, so you can still access these things. This is with respect to the Spark application. However, this is monitored by something called as Yarn application. If you scroll on the left, there's a link here also. This link is the one which will be served by the app timeline server. Okay, so if you want to go to the Spark job level details, all the detailed information with respect to Spark jobs, they are served using this tracking UI, and the app timeline server will actually give you details with respect to this. Okay, you can see the history, and you can click on this, and again it will take you to the Spark history server. This is served by Spark history server, and this is served by app timeline server of Yarn, which is nothing but this one. Okay, if this is down, then you will not be able to access this. That being said, now let's go back to the details and let's understand what happens. We will try to understand the Yarn application lifecycle. Yarn is nothing but a resource management framework. I will reiterate whatever I have explained so far to understand the context around the details or whatever I am walking you through here. Before getting in there, let me take few questions. Okay. So Suyash is asking where can we learn about the keywords used in the code. So Suyash, as I have mentioned to you earlier, if you go to the meetup, if you follow our meetup group, there will be sessions which will be conducted at least 2 per week for next 8 to 12 weeks to cover all the aspects of Spark. And you will start seeing the agenda here. So if you go to the events page of the meetup group, and if you go to the upcoming, you should be able to see the details. I'll be publishing the upcoming month sessions by 25th or 26th of the prior month. So by July 26th, you can actually see the schedule for month of August also. As of now, with respect to Spark, this month there are 3 sessions. One is on July 21st, which is nothing but setting up development environment. Then July 24th, setting up data engineering project using Python. And then on July 30th, we will start getting into the details with respect to quick recap of Python essentials, whichever is required for this Spark or to excel in Spark. If you are already familiar with Python, this will be a quick review. If you are not familiar with Python, there is a playlist in the YouTube channel which you can follow and you can learn. I will share those details as we proceed further. And then by July 25th or 26th, I will announce the events with respect to August schedule. And if you are already part of the meetup group, you will be getting the invitations automatically. Also on LinkedIn, I will publish an article where you will see the consolidated schedule so that you can sign up for the relevant sessions for you and you can take it further. As part of those sessions, we will understand all the nuances with respect to the Spark. Okay, so that being said, so Anand, I don't know about these things, but I have seen quite a few production clusters which are running using Spark standalone. Especially Databricks is running using Spark standalone. You can actually spin up a cluster using Databricks and you will see that it is using Spark standalone. I am also serving a client which is Canadian based, a very big bank, and even that one is using Spark standalone. And I don't know about these vulnerabilities and all. I'm actually sharing the details based upon my experience. So Pachapagari Mohan, okay, Mohan Vamsi, Is the Spark more useful only for reading or processing files alone? This question is very naive. You have to follow the future sessions, and then you will understand more about Spark. Piyush, I don't know whether I'll be covering the use cases anytime soon. I will primarily focus on the concepts more than the use cases, at least for the next 2-3 months. Once I'm done with the Spark, probably I might consider some of the use cases, but not in the beginning. So Praveen is asking resource manager why we can see the Spark jobs completed or failed. How can I know how many records are processed, failed to rerun the data ingestion or the failed records? Okay, so it's the developer's responsibility to actually maintain the track record of it. As part of the applications which I have developed, I typically make sure that this information is captured and stored in a database so that we can actually see the lineage of the data pipelines. If developers are not doing that, then they haven't designed the solution properly. Okay, there is a concept of counters, but counters are not highly reliable. Narendra is asking, I see two methods people generally write code, both written RDDs. How are they different and why such different version? Is it but confusing any inputs? So you have to follow the sessions, Narendra. We will not be using RDDs at all because from Spark it is completely irrelevant. So once you start attending the Spark related sessions, you will understand. Praveen, I can't answer all these questions at this time. You are asking way too many questions and most of them are not very relevant. So please be specific to today's topic. Today's topic is a precursor for the data engineering course, which I'm going to cover. And these are all full-time administrator type of questions. You have to explore and you have to figure out all these things. Okay, I will not be able to answer all these questions. Rishabh is asking, where can we see if any memory tuning is required in Spark jobs using YARN logs? So it's too early to discuss, Rishabh. This is not the right time to discuss on that. This is a precursor for the data engineering using Spark. Chalama is asking, do I have to have basics of MapReduce if I'm starting to learn directly? For Spark 2.x, is it mandatory? Don't worry too much about that, Chalama. We will understand those things as we get into the APIs. Ranjit is asking, what is reason for default allocation to be false by default? So don't worry too much about that, Ranjit, at this time. That is not the idea about this. I just want to make sure you guys understand that Spark can be executed under the YARN and also a bit of details with respect to the YARN cluster. How do we understand when Spark job is taking a lot of time using YARN? Again, this is not the right time. Okay. Yeah, Praveen, please be relevant. I don't think it is relevant for the things which we are covering today. If you are interested in YARN resource allocation and capacity planning, I have shared a YouTube video already. Go to that video. I have covered quite a bit of details in that. Okay. Okay, cool, Anand. That's good to know. So Subhadarshi is saying, is there any best practices specific to Spark? Again, this is too early to discuss, Subhadarshi. This is a precursor for the data engineering course. You have to go to the course before you ask such kind of questions. Okay, so don't worry too much about those things. If you actually follow the agenda, first I'll be talking about setting up development environment for Spark, then data engineering project using PyCharm, and then we'll take it further. That being said, now let us move on to YARN application lifecycle. YARN is nothing but a resource management framework. We can use distributed data processing frameworks such as MapReduce, Spark, etc. by plugging into YARN. How to plug in? At the time of the cluster setup, we will actually tell where the YARN configuration files are, and Spark will understand that it should use YARN when we use Spark will understand which resource managers should be used when we actually use --master YARN while submitting the Spark jobs or while launching Spark Shell or PySpark. So if you recollect, as part of the Spark shell command here, I have specified --master YARN. And as administrator, what we have to do is we have to tell where the YARN related configuration files are. And when I use --master YARN, Spark will automatically know where the yarn cluster is, as long as the configuration files have correct information, and it will start leveraging the yarn directly. Okay, so that's how Spark and yarn will be integrated. We just have to make sure that we tell Spark about where the yarn configuration files are, and while launching Spark, we have to say -- master yarn, and then it will launch using yarn. A yarn application can be MapReduce job or Spark application. When we say Spark shell, it is Spark application from Spark perspective and yarn application from yarn perspective. From yarn perspective, data is being processed by containers. So we use term called as containers when it comes to yarn. But when it comes to Spark, we use the term called as executor. Okay. Let me launch this once again. And then I will take you to the UI. And then I will show you details with respect to executor and all. In this case, I have said num executors as 4, right? Now I can go to the UI here, and I can go to running. This is what is started, right? So it is running now. I can go to application master, and I can go to the executors, and you can see there are 5 executors. Even though I said 4, there are 5. One is for driver, which is on the node from where the Spark shell is launched. So these executors from Spark perspective are nothing but containers from the yarn perspective. Okay, from yarn perspective, we call it as container. Let us understand the lifecycle of yarn application. When we actually say Spark shell or Spark submit, it will create something called as yarn application. What is that yarn application in this case? The yarn application is nothing but, if I go here, so this is what is yarn application. Okay, and you can actually access this Spark UI from using this link, yarn UI using this link. So there will be a yarn application that will be created whenever we submit the job. When we submit the job or when we launch Spark shell, the request will go to the resource manager. And as you have seen earlier, the resource manager will have the up-to-date information. In this case, if you go to here, you can see the details about how many containers are running on each node, how much memory is being used, etc. As resource manager will have up-to-date information, resource manager can understand on what nodes the containers should be created. So when we say containers from Spark perspective, they are nothing but executors. Okay, so there will be one container which is nothing but application master, and then there will be 4 containers which are nothing but executors in our case, because we said num executors as 4. Okay, now how those executors will be created? Once the application master is launched, when we start the job, that application master will talk to the node managers directly, and then it will decide on which nodes the containers should be created so that the data can be processed. So this is how it will look like. So when we actually submit the Spark job, the request will go to the resource manager from the client, and then first it will actually create one container, and that container is called as application master, and that application master in turn will talk to the other node managers in the cluster, or including the node manager on which the application master is running. Even the application master will be launched on the worker node itself. So first, this master process for the job will be created on one of the workers, and then that will actually negotiate for the resources from the node managers based upon the resource availability, and it will start creating the additional containers. You can also review this picture and you can understand. Let me zoom out a little bit. Oh, sorry. Yeah. Now, if you look at this, so there are 2 jobs that are submitted, one by red and other one by purple. So you can see there are node managers. These node managers are on the worker nodes. The client submits the job, it goes to the resource manager, and based upon the load, it will choose one of the nodes to launch the application master. For red, the application master is created on the second node, and then it will negotiate with the node managers, and it will try to create the containers, which are nothing but Spark executors. Meanwhile, if the purple client is submitted, it will check on how the app masters are shared across the nodes. Typically, it will prefer it will take care of load balancing from the application master perspective first. As app master is running on this node, as we have two other nodes in this picture, it will try to create the app master for this purple one on one of these two nodes. Once the app master is created, that app master will actually get the details about the resources on the other nodes, and it will try to create the containers for that job, in this case purple job. And as we are talking about Spark jobs, they are nothing but the executors. From the Spark application perspective, it will be like this. We submit the job for the client. The JVM typically acts as the driver program. It will talk to the resource manager and create the application master. So in this case, I'm talking from the Spark perspective. Earlier, I have spoken from the Yarn perspective. And we'll get into those details when we actually get into the APIs also. At the time, it will start making a lot more sense than now. Even if you do not understand completely at this time, don't worry too much about it. We will submit this job for the client. So in this case, when I launch Spark Shell, even here a job is submitted, and GW01 is the client, right? And it will launch a JVM when we say Spark Shell or Spark Submit, and that is typically called as driver program. That driver program will talk to the resource manager, and it will create the application master for our cluster. For our job, not for the cluster. So in this case, if you go back here, this is the one which is launched when I say Spark Shell, and you can click on this to understand where this is created. It is created on wn02.itversity.com. So on one of the worker nodes, the application master is created. Okay. Then the application master will negotiate the resources from other node managers, and then it will actually take care of creating the Spark executors for our job. In our case, we are asking for 4. All those 4 will be created on the worker nodes. From Yarn perspective, they are nothing but containers. And all those 4 executors are also nothing but JVMs, which can run multiple concurrent threads until the job is complete. Okay, we will actually go through these details once again when we get into the APIs. For now, once again, you can run this, and you should be able to see the details in action if you want, but as I have already ran it, I'm not going to run. Okay, so now when it comes to the clusters, there will be hundreds of jobs that will be submitted over a period of time, and there will be tens of jobs which might be submitted at the same time. And for example, if your cluster have 120 GB memory capacity and 60 vCores capacity, if you are trying to process larger jobs, the jobs might require more capacity than what your cluster have. Instead of failing, what it will do, it will actually queue up the resources and also the jobs, and then it will transition the tasks from pending to processed to complete. Pending to processing to completed. And over a period of time, all the executors, all the data will be processed by the tasks in a sequential fashion once the distributed computing is saturated. So the way all these concurrent jobs and the tasks related to all these concurrent jobs are managed is by using this something called as schedulers. Okay, let's understand a few details with respect to schedulers. Yarn primarily take care of resource management and job scheduling. On top of resource management, it also take care of job scheduling. What is resource management? Understanding how much busy each node in the cluster is called as resource management. What is job scheduling? Making sure that all the jobs and tasks are completed using the resources up to the maximum extent, even if the tasks and jobs are going beyond the cluster capacity. That is called as job scheduling. So Yarn not only takes care of resource management, it also takes care of job scheduling. So when it comes to job scheduling, there are 3 types of schedulers supported by Yarn. It is all about how the jobs and tasks associated with respect to the jobs are queued up as they execute. They are nothing but FIFO scheduler, phase scheduler, and capacity scheduler. FIFO scheduler is default in plain vanilla Hadoop, and it is only used for development purposes. We don't configure production clusters with FIFO scheduler. Either we use phase scheduler or capacity scheduler. In Cloudera distribution, phase scheduler is default. In Hortonworks clusters, capacity schedulers are default. Once again, I'm reiterating, I'm not going to get into all those details at this time, because as things evolved from the developer's perspective, this phase scheduler, capacity scheduler, etc. are not that relevant. Okay, because whatever is configured by administrators after discussing the architects will be using it. But as long as you understand that jobs, there can be tens of jobs which might be submitted concurrently, which require more capacity than what we have in the cluster. And the way all these tasks are served is by using the concept of schedulers. As long as you understand that, that is more than enough. And how to get the information about which scheduler is being used, either you can go to the yarn properties files, or you can go to Ambari and you can actually go through the configs from the UI and you can take it further. So in this case, you can go to Ambari and you can go to configs and you can actually search for scheduler, which will give the details about which scheduler is being used here. It's a Hortonworks cluster, and hence we use capacity scheduler in this case. So you can go to advanced here and you can actually see the details here. So scheduler class is the property which will tell you which scheduler is used. So we are using capacity scheduler. Now, if you go onto the gateway node of the cluster, to which you will get access if you sign up for the labs, you can go to this location called as etc Hadoop conf, and then you have something called as yarn site.xml, and you can actually search for capacity in this, and you can see the property here, yarn resource manager scheduler class, and capacity scheduler is the one which is being used. We can customize the behavior of this capacity scheduler. For that, we will have an XML file, which is nothing but capacity scheduler.xml. This will have the customizations with respect to the scheduling. Instead of cluttering yarn-site.xml with all the nuances with respect to capacity scheduler, we have a separate XML file here. However, when it comes to the web UI, you will get all those capacity scheduler properties like this. You can get into the details, and if you are interested to explore further, you can take care of it by yourself. Okay. So that being said, now let me take a few questions here, and then we'll wrap up. So Subhadarshi is saying, is there any best practices specific to Spark development and cluster setup? Okay, I think I answered that question. Now let me go to the Jishan's question. Whenever you plan to cover PySpark or Spark, please do discuss all the configuration parameters necessary for developers or engineers to know. That will be considered as advanced topic. So if you want to understand what I'll be covering, you can actually go back to the video in the series, which is there as part of the playlist. Okay, you can go into this playlist. Okay, you can I think this is the one which you should focus on, overview of big data certifications. I am going to cover all the content relevant to the big data certifications, both CCA 175 as well as Databricks. I'll be covering content related to both, and those are the ones will be provided free for you without charging anything. You go through that and you understand the curriculum of Databricks and CCA 175. Whatever is covered from the configurations perspective as part of those certifications, only those will be covered. I'll not be going beyond that. Probably as part of the advanced sessions, I might cover those things. This is to answer Jishan's question. And anyone who have confusion about what I'm going to cover as part of these free sessions with respect to Spark in next 2 to 3 months, go to this video overview of big data certifications and you will understand. Prasanjit, the session is started quite some time back. You just have to watch it again. You can watch these things as part of the playlist. So if anyone missed and if you want to go back and watch, you can watch this playlist, and this will be available for free all the time. Then Containers are physically separated, servers are same. So I think I have covered quite a lot of details with respect to containers, Mohan. If it is not clear, probably you have to come back to this again. Jishan is asking if the resource manager was Kubernetes, what would we write instead of ER? So with respect to resource manager being Kubernetes, I am also not sure. I haven't explored Kubernetes in detail. In one of the projects where Kubernetes based cluster is implemented, we are using Spark standalone. Okay, that's all I know about Kubernetes at this time. And Kubernetes is not relevant for this upcoming videos or upcoming series. So don't expect too much with respect to Kubernetes. Mahendra is asking, can we have access to this content when we subscribe for labs? Yes, sure. I'm planning to even include the videos as part of the content very soon, so that you get everything in a unified location. You can use with labs and you should be able to practice. Okay. Praveen is asking, do we have any relation of 128 GB RAM and 64 cores? Can we have 128 GB RAM and 32 cores? Yeah, so you have to go into that yarn tuning session. You will be able to take care of it. So I don't provide on-job support, Praveen. If at all, if you are in a position to make certain decisions, if you can engage me as a consultant to your project, I will be able to support with corp to corp engagement, but I don't provide individual on-job support. Okay. Sneha, how does fair and capacity schedule work? I'm guessing FIFO is first in, first out. Yeah, so there are videos in my YouTube channel if you are interested, or if you are keen about fair scheduler or capacity scheduler, you can go to my YouTube channel and search for ITVersity, or you can go to YouTube and search for ITVersity schedulers, and you should be able to see some content. Okay. But as a data engineer, don't break your head. You should spend your energy in understanding the Spark APIs, Kafka, NiFi, etc., instead of getting into those internals. Rishabh is asking, how can we define cluster size if we are processing 20 terabytes of data every day? It's very specific, and I can't answer that question. There is no thumb rule for that. There has to be thorough capacity planning that has to go through, and hence I will not be able to answer that question, Rishabh. So that being said, that's it for today. And what are the upcoming events? Let me reiterate. The upcoming events are nothing but on July 21st, we have Apache Spark setting up development environment. You can actually access all these events going through this link. So if you want to understand how to set up development environment on a single node, this is the session you can attend. On 24th of July, we'll be setting up a data engineering project using PyCharm. On 27th of July, we will be starting with a new series, Mondays series on NiFi. Every Monday, I will be covering NiFi. So the first topic will be data ingestion using NiFi, where I will be giving you the overview. And then on August 3rd, we will be looking into the aspects of setting up development environment for NiFi. So with respect to NiFi, the live sessions will be free, and they will be made available for a couple of weeks after each session. And then they will be member only. So there will be quite a lot of member only content very soon. And if you want to get access to that member exclusive content, please subscribe to our channel as a member rather than a shared subscriber. How to become a member? In all these events, there is a link to become a member. Towards the end, you have joined this channel to get access to perks. So this is the one which you can use to become a member, and you should be able to access it. Okay. So that being said, and thank you, and let's stay connected, and feel free to join the sessions live via Meetup or start watching the pre-recorded videos. In case if you want to get the notifications whenever the events are conducted, subscribe to our Meetup group and RSVP to the event so that you get the notifications. Thank you, and let's stay in touch. Bye. Okay, there is a question from Zoom. Let me take that question if the person is still there. Okay, do